During busy hours, students, professors, and office workers are often seen carrying a cup of coffee around. But have you ever wondered how long does it take to produce a cup of coffee? It may only take you 3 minutes to get a cup of coffee from Starbucks or Pacific Coffee, but it actually takes up to 26 hours to produce a cup of coffee. So greetings to Professor Cui, Jing, and fellow classmates. We are Group 11. I'm Zoe, and this is Jennifer, Prabhav, Peter, Subin, and Nicholas. And today, we'll be exploring the production process of natural and pure caffeine by studying the Indian company Sri Ahimsa Mines and Mineral Limited. Let me walk you through the agenda for today. Sri Ahimsa faces three main operational challenges, namely bottleneck, low yield rate, and unstable supply of raw material. The key question lies in how to reduce the costs incurred by the operational inefficiencies. Through detailed analysis of the major problems, we will present 4 key recommendations. Before we delve into the issues faced by Sri Ahimsa, let me introduce a bit more about the company. Based in India, SAMM is a manufacturer of premium and quality natural caffeine. This caffeine has a variety of applications, mainly related to additives in energy drinks as well as food, for example, frozen desserts, yogurts, and chocolates. Sri Ahimsa adopts the batch process production. It first extracts elements from plants, then refines the caffeine. Afterwards, it packages the products and exports it worldwide to global consumers, including Africa, Middle East, Eastern Europe, and North America, showing that the company is running on a large-scale operation. Let us investigate the production process of the company to analyze the bottleneck problem. Prabhav will further explain to you.
Now, in order to know about the production process of Sri Ahimsa Mines and Minerals, let's look at the process diagram of the production. Initially, the crude caffeine is put into the process reactor with water, wherein lime activated charcoal are added in order to make the reaction happen. This is further passed on to the filter press, wherein impurities are removed to another part. After the filter process, there is a quality control check in order to ensure that the impurities which are removed are making the material more pure. It is further added to the cooling reactor 1 so as to cool down the material extracted and further process the material. Further, it is put into the centrifuge machine so as to split all the parts of the material into different stages. After that, the same process is repeated 3 times till the drying process of the material. This whole time before the drying process, it takes 2.5 hours to process the whole crude caffeine into pure form. The dryer in itself takes 20 hours to dry the material in the storage space area where the material is led to be stayed. Further, it is passed on to granulator, wherein the metal detector is used to remove all the metal and other instruments in the extracted product. Further, it is sent to grinding and then magnetic separator. Further, C-weighing and weighing are done. This leads us to packaging of the product, and then the testing happens. Further, the goods are stored. If we move on to the bottleneck, we notice the drying process takes 20 hours for one batch to dry. Each batch size ranges between 2000 kgs to 3000 kgs, which is produced in 24 hours in total. So, as we know, 20 hours of the drying is the bottleneck. Time for each batch to dry takes around 83.33% of the total production time. Therefore, the maximum capacity for drying it once is limited to 4,000 kilograms in the storage area. As a result, the upstream resource takes 2 hours 30 minutes to process the crude caffeine. Further, the drying process as the bottleneck takes 20 hours, and further, the downstream resources take 1 hour 30 minutes in order to uh, granulate and finally pack the material. So if we see in maximum, two batches of product of 2000 kilograms each can be produced within 26 hours 30 minutes. If we see the time, let's say at 12 o'clock in the morning of day one, the first batch is started to produce. It is input to the bottleneck resource at 2:30 a.m. of the day one. From the drying process, it moves to the downstream resource at 22:30 hours, and further, the final product is ready at 12 a.m. of the other day. This takes 24 hours. If we consider the second batch can be started at 2:30 a.m. of day one, wherein the first batch is just removed from the upstream resource. Therefore, the combined time of the two batches is 26 hours 30 minutes, which is limited to the maximum potential. Now, Jennifer will talk about the quality maintenance.
Apart from the bottleneck, let's look at the general operation of this company. SAMM is pretty responsible for quality. It has multiple quality check systems and multiple working cycles to make sure that the output is adequate and valuable. Therefore, for the quality management, there is no obvious drawback. However, looking from the efficiency side, many problems raised. We find that the yield loss is great because of the leakage of machine. If there is seldom breakdown for machine, the producing yield should achieve 90%. When machines occasionally need repair, the production line has to be influenced, and therefore the final yield would drop to 80%, which greatly affect the efficiency. Not only for machine, but also manpower needs to be improved. From the interview with the CEO of this company, we got to know that some of the workers in the plant are not trained and skilled. Well, it is a complicated issue because the salary level in India is increasing, but the percentage of skilled workers is decreasing. A recent research showed that 80% of workforce in India does not possess skills that could be beneficial for the business. There is also an external component that's crucial to this company's operation, which is supplier. The supplier is in Europe, providing raw materials, but on average, it will delay delivering for 7 to 10 days. It makes SAMM hard to react efficiently to sudden demand with the high underage cost. Next, Nicholas will analyze the product process metrics.
In order to recognize the production process of SAMM, several criteria should be considered. The first criterion is product variety. Generally, low product variety implies a rigid production process and probably a mass production. Production scale is actually another criterion should be considered. A large batch size or a large-scaled production enables a reduction of average cost and the utilization of capital. So a large-scaled production involves more machines and tends to be rigid. The third criterion is labor content and labor skill. A rigid production process lead to unskillful labor only, because a rigid process involves more machines. Apart from labor, the amount of capital investment decides the production process as well. Usually, a rigid, well-defined production process requires more capital investment than a flexible one. Machines and software are more tremendously demanded in a rigid process. Knowing these criteria, I will pass to Sobin to evaluate the situation of SAMM for you.
SAMA is a focused manufacturer which is a low product variety with their main production, which is standardized caffeine. The company's high production volume-based process do require the labor content process. However, it only requires unskilled labor during 4 production stages out of 19 to 21 production stages of the company in total. Therefore, taking into account these four criteria, which are low product variety, large production scale, unskilled labor contents that needed for only 4 stages out of 19 to 21 stages, and the aim to utilize the SAMM's capital, machine-based process is the most suitable product process for the company. Now Peter will explain recommendations to improve the operation efficiency.
Understanding the various room for improvement for SAMM, we have divided 4 recommendations aiming to alleviate and improve the operation efficiency. Firstly, improvements should be made to the bottleneck process. The business currently has a limited capacity of 4,000 kilograms of extracted caffeine products, which limits the capacity of the business. Understanding the bottlenecks process as the conversion from the crude caffeine to anhydrous caffeine for future drying. We can produce more anhydrous caffeine from more upstream resources through improving the machinery used in a bottleneck process. One possible way to improve the production capacity of the machine is to increase the drying area of SAMM, so it can accommodate 8,000 to 10,000 kilograms of products, as shown by the graph on the left. This is made possible by utilizing an improvements made to the spare storage area at the manufacturing sites to avoid the problem of damp walls, for the product to dry faster in a proper manner. With the improvement in availability of a bigger area to dry the products, as indicated by the graph on the right, 10 batches can be dried within 2 days, when compared to only 3 batches with older space. It can help SAMM to accommodate double amount of products in a shorter period of time, potentially increasing its productivity from 6,000 kilograms to 20,000 kilograms, given that each batch size is 2,000 kilograms within 2 days, helping SAMM to supply more anhydrous caffeine to the market, allowing it to accommodate increase in market demand. Secondly, improvements should be made to the stability of supply of crude caffeine. Facing situations of delayed supplies of crude caffeine from Europe, SAMM tends to miss the opportunities emerged from short-term demand surge. To prevent missing out on such opportunities in the future, SAMM should negotiate for financial compensations from suppliers in case of delayed supplies. Understanding the vitality of supplies to the whole production process, delayed in supply should be compensated, especially when the suppliers are long-term stable partners. Such incentives/penalty system forces suppliers to make faster deliveries. Additionally, the current supplier tends to raise the price of crude caffeine rapidly within a short period of time. To avoid such price fluctuation that adversely impact cost estimations, SAMM can change the supplier to Caffeine Kopangi from Germany, which tends to provide faster deliveries at a 5% lower price level. As a result, SAMM can receive the supply of crude caffeine earlier and start the production earlier. Apart from this, SAMM might try and order larger quantities of crude caffeine, which leads to an increase in batch size to take advantage of the increase in drying area, as mentioned in Recommendation 1, to promote inventories to meet a short-term increase in demand. Improvements should also be made to the skill level of labor. The mishandling of product raised from the relatively low skill level of labor makes SAMM lose work-in-progress inventory at a higher rate. Such yield loss incurred from human errors has its cost implications on SAMM. Therefore, SAMM can consider the initiation of a hands-on approach training session for the production line labor, such that they tend to handle the production safely and carefully to avoid spilling and contamination. Instead of focusing on instructions giving, showing the labor how to complete their tasks competently is a better way for low-skilled labor. Such provides a short-term resolution to problems where in the long term, potential of increase in mechanization or the hiring of higher skilled labor can be considered. Finally, the multiple leakage points in the upstream resource machinery leads to a relatively high yield loss from the system, lowering the production capacity at SAMM. While improvements to the machinery to fix such leakage can require big initial investment, through repairing or replacement as appropriate based on the conditions of the old machinery, the yield loss is reduced significantly from the system, resulting in a much higher efficiency and output per unit of input. Therefore, the cost of production may reduce over time, leading to increase in profitability for SAMM in the future.
To sum up, after analyzing the operation inefficiencies of SAMM and through identifying their respective causes, we proposed short-term strategies of increasing drying area to improve the bottleneck, and a change in suppliers to promote price stability and reduce fluctuation in delivery time. In the long term, betterment in skill level of labor, promotion of mechanization, and repairment of machinery leakage, while requiring large capital investment, can benefit the business greatly, where it reduces overall yield loss and improves the overall operation efficiency. Thank you very much.